Hey everybody, thanks for stopping by the EFISystemPro YouTube channel. Today we are doing a full Holley Sniper EFI install on a 74 Nova. We're doing full Hyperspark, tank sync tank, and a Sniper 1. Now I'm sure one of the first things you said when I said Sniper 1 was why not a Sniper 2? And we have some reasons for that. The main one is that this car is eventually going to have a turbo. And while the Sniper 2 can run with a turbo, it doesn't have the ability to control boost with a boost solenoid. So we're going with the Sniper 1 to be able to control boost. Now the installation of the Sniper 1 and Sniper 2 are very similar. The areas where they do differ, I'll be sure to explain the differences there. And you can use this video to install a Sniper 2 also. So let's do a quick overview of the parts we're going to use and then we'll get started. As we said here with the Sniper 1, this is a 550-516. It's just the 650 horsepower, 4150 Sniper 1. It's good to about 500 horsepower with boost and about 650 naturally aspirated. Next, as we move over, this is our plumbing kit that we have put together to give you everything you need to put a tank sync tank in your car. We have all the fittings necessary, all the hose you'll need for the soft line on either end and a full return line. Normally, if you're putting a Sniper 1 in with a tank sync tank, you won't need this fuel pressure regulator. We do need this because with boost, we need to be able to increase fuel pressure with boost pressure. But normally you would just use the regulator inside the Sniper, and this kit covers that. It also has these additional fittings for the fuel pressure regulator. Moving over here, we have the full Hyperspark kit. 550-300 Distributor, 556-154 Hyperspark 2 ignition box, and the 556-152 coil. Also included with the ignition box is the full wiring harness for those. Then we move down to the tank sync tank. All the gaskets and hardware included. The fill neck and coupler are included. And not pictured are the straps to hold the tank in. That's all included in the kit. So now that we got that out of the way, let's get started on the install. All right, so real quick, let's go over the car. This is the 74 Nova. It has been converted to a full drag car, completely gutted, had zero wiring in it. Has a little bit of a roll cage in it. Had a fuel cell, battery moved to the back, things like that. This is slowly being converted to a street car to do drag and drive events like Sick Week and things like that. We're also using this to do a lot of testing for EFI products and videos like this to show you how to use those products. So I wanted to mention real quick just that it was a full drag car and completely gutted, because I know as you see things happen in this video, you're going to have questions about, why is all the interior out? Things like that. So I've done my best to get this back to a point where it would be a lot like what you're installing. It has a full wiring harness again, starts with the key and all of that. It doesn't have a switch panel anymore. And that's why we're going with the factory replacement tank to make this as close as we can to what you're all working on. All right, so step one of the instructions assumes that you have removed your carburetor already because you were so excited when the Sniper showed up and ready to put it on. But the actual step one says to label all your vacuum hoses so you know where they go back. Well, we don't have any on this car, so we're not doing that. The next thing is to clean the mating surface for the Sniper, and we've done that. So now we put a gasket on and drop the Sniper on. So the directions say 60 to 80 inch-pounds. It's definitely not foot-pounds. And so we're going to shoot for 70 right in the middle. And they say to do a cross pattern. All right, so this is where you want to hook back up any of your vacuum lines that you had. Also your linkages for your transmission or your throttle. Now this car has a full manually shifted 4L60, so there are no transmission linkages. And like we said in the beginning, there's no vacuum hoses of any kind. Now one thing I do want to touch on about vacuum, a lot of people ask about where can they hook things up and things like that, and also about PCV valves. As far as the Sniper is concerned, any vacuum source is the same as any other vacuum source, except for the ported vacuum that is for a vacuum advanced distributor. Now that ported vacuum is this one right here, and it's only active over about 10% throttle. Under that, you don't get any vacuum from that source. Now, as far as your brake booster goes, PCV valve, things like that, they can really hook up anywhere that the hose fits. And one thing to note is if you have any sort of vacuum ports on your intake manifold itself, those are going to act exactly the same as any other vacuum ports. So really it's about what's the most convenient. Another note about PCV valves, a lot of times they can cause idle issues. You have a lot more vacuum when you're decelerating than you do at idle. And while you're decelerating, that can open your PCV valve more. Then when you get down to idle, the RPM is still kind of high, which is also creating that higher vacuum and keeping the PCV valve open. You shut the engine off, start it back up, and it's back to normal. If you have that problem and you need to keep the PCV valve connected to vacuum, the best thing to do is a fixed orifice PCV valve, and that'll help solve that idle problem. Okay, next step comes to the oxygen sensor. And this is a very important topic. The directions say 6 to 10 inches from the merge of the exhaust runners. So people always ask me this question of where exactly is that measurement? Well, that starts here. After all 4 pipes have merged, you want 6 to 10 inches from there. So we'll measure. And that gives us basically from this weld to this weld. Now, another really important part of this is the angle that the sensor is in the pipe. You want it to be in that 10 or 2 o'clock position is ideal. You can go up a little higher if you need to, just for clearance, but you really don't want to come down from there. And the reason for that is moisture collected in the bottom of the exhaust will collect in the sensor. That will ruin the sensor. Another tip when it comes to moisture and oxygen sensors is if you ever start your vehicle with the sniper installed, you want to run it long enough to heat up your exhaust system. If you don't heat that up, you have hot gases inside of a cold pipe, and that creates condensation. That condensation collects on the oxygen sensor and will ruin it. So if you ever start your vehicle with an oxygen sensor, you want to run it long enough to get this pipe hot. That way the exhaust inside and the pipe cool down at the same time and then don't create moisture. Okay, oxygen sensor is in. A little above the 10 or 2 o'clock position, but you can see for space reasons I had to. And then all of this length, you really got to do a good job of tying that up. If any of this touches the exhaust, it burns through, and when it shorts out, it'll ruin the ECU. I can't tell you how many times I've had to give customers that bad news when they've called me up with that problem. So I'm going to pull that up behind the bell housing there and tie it up kind of halfway between the top of the engine and the bottom. All right, so next is the coolant temperature sensor. And I already had it in here because I needed to plug this. It was what I had handy that fit. But basically you can put it in the intake manifold where the coolant crosses over from one cylinder head to the other, or you can put it in either cylinder head. Any of that's fine. What you don't want to do is put it in your thermostat housing. Your coolant temperature above the thermostat is going to be a lot colder than what's in the engine until the thermostat opens. So that's going to throw off all of your cold start settings and the way it runs cold and all of that. You also want to make sure you put a little bit of thread sealant on the threads so you don't have a water leak there. Now the next thing in the directions is hooking up the fuel lines, and since we don't have a fuel tank or anything at the moment, we're going to have to detour and do the fuel tank installation. So let's get to measuring for the length for the pump and the fuel level sending unit and get this done. So the first thing we need to do is cut the return line so it's just above the bottom of the fuel tank. It needs to be all the way at the bottom but not quite touching, because you want the fuel to enter the fuel level in the tank under the top so it doesn't splash and create bubbles. So the tank depth is 9 inches. So we'll cut this at 8 3/4 to give us a 1/4 inch space at the bottom. So now we remember our 9-inch height that we have here. You measure your fully assembled pump with the filter. So what you want is you want this filter to just graze the bottom of the tank. Even if it's quite not touching, that's okay too. You don't want it pushed up hard against the bottom of the tank because that'll block flow. So we got right at 4.5 inches from the very bottom here where the hose slips on here. So then we need to subtract that from this tube length and cut this tube, and that should put us at the right height. So now that we have our pump fully assembled, we're going to work on the fuel level sending unit and get it adjusted for the height. All right, so for starters, this extension bracket needs to be removed. It comes fully assembled, and since our tank is 9 inches, it's between the 6 inches and 15.5 inches. They say does not need this. So we're just going to be working with this and get the height adjusted there. So now with that bracket removed, we need to set the distance from here to here at half of the tank depth. So for a 9-inch tank, it's 4.5 inches. All right, so now that we're cut to half, from here to here is half the depth of the tank, install the float, bring the float all the way up, and you want to be an 1/8 inch below the bottom edge here. So then with the gasket, you end up right at the top of the tank. And for good measure, you can check it here that you should be just short from here to here. You should be just short of your tank depth of 9 inches in this case. Then what you do is move it all the way up and cut just past where it touches here so you don't have all this extra. All right, so now that we're all set here, we can drop this in the tank. All right, so while it's easy to get to, we're gonna go ahead and install our fittings in here. Now these are 1/4 inch pipe thread, and they need a PTFE sealant. So this is what I like to use. There's a bunch of them out there, but this does a great job. So one thing that I get asked about is when you're mounting this bracket to the regulator, it goes here, that there's no threads in these holes. And it comes with these screws, and you're meant to just force them in there, and they'll cut their own threads and tighten down, and it'll work. I know it sounds a little odd, but that's the way it's meant to go. So now that the tank's in and the regulator's mounted, we can talk about how we're going to run fuel lines here. Normally, if you weren't going to run a turbo setup and you were just going to use the internal regulator, I would feed in over here where it comes with the factory fitting for the inlet. That'll fill all of this, cross over this tube, fill all of this. It'll use this regulator, come out and go back to the tank. All right, fuel lines are finished here. We've got this one from the tank, the pressure line, comes into the regulator, comes out of the regulator up to the throttle body here. The throttle body's capped off everywhere else, so it's a little, very slight deadhead from here to the throttle body. Then we got the return line from the bottom going out. Now there's a couple different ways you can hook these things up. This is one way that sort of deadheads to the throttle body, and the other way would be to cap off one of these two ports. It doesn't matter which one. Feed your feed line to the throttle body, out of the throttle body into the regulator, and then return line back to the tank. Depending on the vehicle, some are easier set up that way than others. This just worked out for this one. All right, so one question I run into is about these gauges, and that sometimes they aren't reading accurate. And one thing that can happen is where it's manufactured, the atmosphere pressure there might be different than where you are. So the air pressure inside causes it to be inaccurate, and it's a pretty easy fix. You notice there's fluid in it, so you don't want to spill any of that. So you flip it over this. So you flip it over this way so none of the fluid can come out. Just pop this open, let the pressure equalize, and put it back. That's all you got to do, and then you're good to go again. This really isn't something you have to do on every installation. It's just if you see that your pressure seems really inaccurate, you can do it. But if you want to do it, you're not hurting anything. All right, so now that the fuel lines are done, we're going to get on the Hyperspark distributor and get that dropped in. And we'll get the ignition box wired up and be one step closer to getting this thing fired up. So let's hop in here and get this going. So the first thing we need to do is get #1 cylinder on top dead center. And we can drop the distributor in and use the clear cap to keep it lined up where it needs to be. Two things you don't want to forget. One is your gasket. And second is the lube for the gear. This is a brand new gear. So you want it lubed up for that first startup. Alright, so once you have your gasket and your lube, make sure the sniper logo is facing forward. Drop it in with the rotor pointing at the #1 cylinder. All right, with the distributor in, pointing at #1 cylinder, we're just going to loosely put the clamp on. finger tight so you can still move things. And with the clear cap, all right, so with the clear cap fully seated on there, and everything's locked in place, we'll go ahead and tighten down our hold down bolt. One thing a lot of people ask me about or get confused about when they're putting the cap on and they're looking at the rotor kind of where it lines up, they say that it's past the #1 terminal on the cap. And the reason for that is the engine's at top dead center, so you're well past where it would normally fire. So since it's past that point, the rotor should be past this terminal. If you had it at, say, 15 degrees before top dead center, then the rotor would line up better with this terminal here. So hopefully that clears that up, because I get that question quite a bit. All right, so next up, this is the sniper main harness, and this is your ignition input. This harness comes from the Hyperspark distributor, plugs in right here, and then this pink wire is a key on 12 volt. One thing you really want to try to do is not to tie this together with the sniper pink wire. I know it says that in the instructions, and a lot of times you can do it and it works okay, but I have seen times where there is electrical feedback from the distributor that causes issues with the ECU. So if at all possible, try to avoid connecting those two pink wires to the same source. Now, as a last resort, you can do it, you want to keep an eye on things and make sure that you're not getting any kind of interference. That also leads to one difference between the Sniper 1 and the Sniper 2. The Sniper 2 has this same 3-pin connector, and you don't have to connect this pink wire to a key on 12 volt. It's all done through just the one connection. Now, for those of you that aren't using a Hyperspark distributor, you have a few options. If you just have like an HEI distributor or a stock points distributor, you'll use this yellow wire. On a stock point setup, this yellow wire will go to the negative of your coil, and in an HEI distributor, this will go to the tach output of the distributor. Now, if you have a tach in your vehicle, you'll need to connect that to the Sniper brown wire, which is a tach output. A lot of times you can connect the yellow wire and your tach to the same pin on the distributor. I have seen issues backfeeding interference from the tach to the Sniper, so that's something to keep in mind. Since the Sniper has a tach output, it's easy to just connect to that, just to your RPM source, and you're good to go. If you have an ignition box, you'll need to use this wire. It plugs into the same connector for the Hyperspark distributor. It only has a purple wire, and that will go to the RPM output of your ignition box. And same thing with your tach in the car. If you have one, you'll want to remove it from that tach source. Use the brown wire from the Sniper or the gray in the Sniper 2 to feed the tach, and let this feed the Sniper. One last note about the key on pink wire, and this goes for the Hyperspark distributor, the ignition box, and the Sniper itself, Sniper 1 and Sniper 2. You want to make sure you connect that to a source that has power with the key on and while cranking. A lot of these circuits cut out for startup to allow all the power to the starter, and if you get one of those sources, it's either not going to start or you're going to have a real hard time getting it to start. If you're doing the full Hyperspark setup, the wire that was originally for the coil is a great one. But if you're not doing that and you're keeping your coil powered by that wire, you don't want to use that one. Another popular one that works great is the electric choke wire, because it has power at all times. But it's important to disconnect your starter, use a multimeter, keep working the key, checking with a multimeter, and see which circuits have power both ways. So it's a little hard to see here, but down here you can see the feed line that's going to go to the Sniper throttle body, and it's going into this gas can here. I like to just jump the relay on the pump and make it run for just a couple seconds. I like to just run that for a couple seconds, flush any debris out of the lines, and it just keeps the injectors safe. You don't want to clog one of those injectors, because then you're stuck dealing with that. Well, you can see I forgot to tighten that line, so it's leaking a little bit, but we got it purged out, so we'll hook it back up, run through the setup wizard, and get this thing fired up. All right, here we go. We've checked for leaks, we've set fuel pressure, we've purged the lines, everything's hooked up and ready to go. So I'm gonna set this camera up always on with no edits, and I'm gonna have the other camera on the screen. I'll put them both up here on the display for you to see. And we'll go through the setup wizard and fire this thing up, see what happens. All right, so let's start with the setup wizard here. It's a 550-516. So I'll go next. 8 cylinders. Engine's 350. Target idle 750. We got a stock cam. No power adders, at least yet. We have Hyperspark distributor. Standard Hyperspark. Let's do wide open throttle timing at 34. All right, we'll cycle the key and see if this thing starts. Well, it seemed just maybe a tad rich when it first fired up, but once it lit off, it was going. So now we just need to sync the timing with the timing light, get it all warmed up, set the IAC, and then we can start driving. So now that it's running, we're at probably the most misunderstood step of the installation, and also the most overlooked. I guess because people don't understand it, they don't do it. And it could not be more important. This is using the static timing function to sync the distributor with the crankshaft. A lot of times people will say that you're syncing it with the ECU, and that's kind of backwards. The ECU knows exactly where the distributor is. Every time the reluctor wheel passes the sensor, it tells it that it's 57.5 degrees before top dead center. But that doesn't mean that it's matching the crankshaft. So let's get into that and see if we can clear that part up. Now, I've tried every way possible to film syncing the actual timing to what the sniper's trying to do. And because of camera frame rates and the flashing of the timing light, I just never could get them to line up right and show you what's going on. So we're gonna do this without the engine running, just to kind of show you what you have to do. Now you'll wanna set this to a number that you know your engine can idle well at, but also that you can see easily on your balancer. So we'll open that up, clear it out. I know this engine will run well at 10 degrees, and I can see that pretty easy on the balancer. So we'll put 10 and hit save. So once that's up, then you hit set. Now, as long as this screen is up and that says 10, so the ECU is going to fire the coil at what it thinks is 10 degrees, but all it has to go on is the distributor. And if you move that distributor, then it's going to throw your timing off. So since the engine's running and the ECU thinks it's firing at 10 degrees, we'll come down here. Okay, so if the engine's running and you're looking down here, you can see that that mark is on 8 degrees. So what that would mean is that the distributor is a little bit behind. So you would loosen the hold down bolt, turn the distributor counterclockwise just a little bit, and then you would come back down and look. Then once you rotate the distributor a little bit, you get your timing light and you look back down here again. Now you can see that we're at 10 degrees. So once you do that, you lock the distributor back down, and now the ECU is trying to fire at 10 degrees and it's actually firing at 10 degrees. So after you've done that, you come back here and you hit clear, and it says static timing cleared. That means it's not using this screen anymore. Static timing isn't a setting, so once you clear that, it's not using the static timing anymore, but whatever the ECU is trying to do is what it's actually doing. So when you set your idle timing at 15 degrees, that's what it's going to be in the engine. And then when you're tuning, say, at the track and you make a pass at 32 degrees of timing, and then you want to see if 2 more degrees is going to make it faster, you put 34 in there, and that's what's actually going to happen. If you don't do this, you could be guessing, and you think you have 32 degrees in it, but it might be 34, and then you make a pass and say, well, let's see if it's any faster. You put 2 more degrees in it. Now you're at 36. That might be too much for your engine. You know, or it could be the other way around, and you're fighting a problem of it being lazy and things like that, and you can't figure out why because you're putting timing numbers in it that make sense to you. So this is a very important step that gets skipped very often. All right, so we're at the point of setting the IAC, or the IAC, the idle control valve, idle control motor. It's got a lot of names and it has one job. So let's jump in here, get that set, and we'll be wrapping up on this sniper install. Okay, so here you can see that the idle is at my target of 850, but the IAC is at 44 or 46%. Coolant temperature is all the way up at the normal operating temperature. Then I start opening the throttle blades with the screw, and you can see the IAC coming down some, but then it gets to 2%. Suddenly it shoots to the hold value, and then you're stuck there. So you have to shut the engine off and restart it to zero the TPS again. So now you can see that the IAC is lower, TPS is back at 0, and we'll open the throttle blades more to try and get that target IAC. But the same thing's going to happen again, and we'll have to shut it off and restart. So now we went just a little too far, so we'll have to close the throttle blades just a little bit and get it back where it needs to be. And it's a good idea to flip the throttle between adjustments. So there we go, we're all set at the target idle. IAC is 1 or 2, maybe 0%, a little bit here and there, that's not a big deal. And now we can do it the other way around, of opening the throttle too much and bringing it down. Okay, so now that you've seen how to set it from the throttle blades being too far closed, now let's set it with the throttle blades being too far open, which is my preferred method to do anyway. So what we'll do is we'll go over here to the idle screw, and we'll just give it a half a turn. And that should put us at too high of an idle, and then we can bring it down. Okay, so here you can see the idle is about 100 RPM too high, IAC is at 0, and we're just slowly backing off on that screw and giving the throttle a little blip every time. You can see we're getting a little closer. We're staying under 900 for the most part. And it looks like one more adjustment's going to do it. Yeah, there we go, down where we need to be. Very little IAC right at the target. All right, so that wraps up the sniper installation. If you have any questions, throw them down in the comments, shoot us an email. Maybe we can try to help you out. If there's any videos like this you want to see on sniper tips and tricks, Terminator X, any of that stuff, let us know, and if there's some interest, we can make it. I'm always looking for ideas and things that can kind of keep you guys going, without our help when we're, out of the office and things like that. So hopefully you got something out of this, and we'll see you in the next one.